I like RO say something.
Hello, welcome to week 12. This is Mr. David, your Algebra 2 teacher. Week 12 is about solving square root equation and other radical equation. At the end of the lesson, you should be able to solve square root and also you should be able to solve radical equation. Please have your textbook and open page 390. In this lesson, we are going to learn about how to solve square root equation, and we'll see a key concept for solving square root equation. And also we are going to see how other radical equation is going to be solved. Then we'll see how we are going to apply radical equation in our real life situation. And also we are going to check whether a given square root equation or radical equation has an extraneous solution. And finally, we'll see equation involving two radicals. Please, dear student, at the end of each problem, you should practice the guided question from your textbook. So these are all about the content of week 12. Now directly I will proceed to the key concept. The key concept is about how we are going to solve a square root equation. In order to solve a square root equation, you might be required to square both sides of the equation. In order to the reason why we square both sides of the equation is to eliminate the square root so that we can easily simplify the equation. Now let's go to problem 1 from your textbook. Problem 1 is about solving a square root equation. What is the solution of 3 plus the square root of 2x minus 3 is equal to 8? What do you think will be the first step for solving this equation? Yes, in order to solve this equation, our first step should be to isolate the square root. In order to isolate the square root, the first thing that I need to do, I need to remove 3. So to isolate the radical expression, I need to remove 3. 3 is positive. Since it's positive, in order to remove it, I need to subtract 3 from each side. When I subtract, I'll get the square root of 2x minus 3 is equal to 5. As you can see, I isolate the square root. Then I get a square root equation. Then what do you think will be the next step? The next step is to eliminate the square root. In order to eliminate the square root, I have to apply the key concept. What the key concept says? The key concept says that to remove the square root, square each side. So let's square each side. When I square each side, I get 2x minus 3 is equal to 25, which is a linear equation. And we know how to solve a linear equation. So to solve this equation, I have to add 3 on each side. Then I get 2x is equal to 28. Then to get for the value of x, I have to divide each side by 2. Then finally, I get x is equal to 14. Mind you, whenever we have a square root equation, after we solve the equation, it's very important to check our answer. In order to check our answer, what we need to do, we just plug the value of x into our original equation. So when we check our answer, it will be 3 plus the square root of 2 times 14 minus 3, which is going to be 8. So our answer is correct. Mind you, in most cases, whenever we have a square root equation, it's very important to check our answer. Okay, this is about problem 1. Let's go to problem 2. Problem 2 is all about solving other radical equation. What is the solution of 3 into x plus 1 to the power of 2 over 3 is equal to 12? What do you think will be the first step? Yes, the first step is to isolate the radical expression. In order to isolate the radical expression, what I need to do, I need to divide each side by 3. So I will get x plus 1 to the power of 2 over 3 is equal to 4. What do you think will be the next step? The next step will be I have to eliminate the radical exponent. In order to eliminate the radical exponent, I have to multiply the radical exponent by its reciprocal. That means I have to raise each side to the 3 over 2 power. This is just to eliminate the radical exponent. Then I will get x plus 1 is equal to 4 to the power of 3 over 2. Here, one thing that you have to be careful that the radical exponent, which is 2 over 3, have a numerator which is even. Because of that, I'm going to have an absolute value equation, which is the absolute value of x plus 1 is equal to 8. Then to solve the absolute value equation, as you learned in the previous quarter or grade 8, it will be x plus 1 is equal to plus or minus 8, which means that I'm going to have two equations. So I have to solve each equation. The first equation is x plus 1 is equal to 8, and the other one is x plus 1 is equal to minus 8. So solve each equation and you will get x is equal to 7 or x is equal to negative 9. You can check your answer by plugging each value of x into our original equation. This is problem 2. Then I will proceed to problem 3. Problem 3 is about the application of radical equation. Okay, let's go to problem 3. Using radical equations. Okay, I'll read the equation. For meteor craters in Arizona, the formula d is equal to 2 times the cube root of v over 0.3 relates the diameter d of the rim in meters to the volume v in cubic meters. What is the volume of the meteor craters? All values are approximate. Here, what's given, the diameter of the crater is given, which is 1.2 kilometers. And we are asked to find the volume of the craters in cubic meters. So one thing that we need to be careful about the units, because you are asked to express your answer in terms of meters. So let's solve the problem. I'll begin with the equation. The equation d is equal to 2 times the cube root of v over 0.3 relates the diameter and the volume. Since you are asked to find the volume, you need to solve for v. So to solve v, you have to divide each side of the equation by 2. And you'll get d over 2 is equal to 2 over 2 cube root of v over 0.3. Then the next step will be you have to remove the cube root. To remove the cube root, you have to cube each side of the equation. Then you will get v over 2 to the power of 3 is equal to v over 0.3. Then it will be easy for us to solve for v after this. So to get for v, what you need to do is just multiply each side by 0.3. So you'll get 0.3 times d over 2 to the power of 3 is equal to v. We solve for v. Then the next step will be, it's very easy. You just simply substitute for the value of d, which is given 1,200. Here I converted 1.2 kilometer to meters by multiplying 1.2 by 1000. So I'll get 0.3 times 1200 over 2 to the power of 3 is equal to V, which will be 64,800,000. So this is the application of radical equation. Now I will proceed to problem 4. Okay, on problem 4, you are asked to check for extraneous solution. What is the solution of x plus 7 minus 5 is equal to x? And check your result. So let's solve this one and let's see what we are going to get. So first I'm going to solve the square root of x plus 7 minus 5 is equal to x. What do you think will be the first step to solve this problem? Yes, in order to solve this problem, I need to isolate the square root. So to isolate the square root, the first thing is I need to remove negative 5. So to remove negative 5, I have to add 5 on each side. So plus 5 plus 5. Then this will be cancelled out. Then I get square root equation. So it will be x plus 7 is equal to x plus 5. X plus 5. As you can see, we get a square root equation. So to solve the square root equation, we are going to apply the key concept. What the key concept says: to remove the square root, you have to square each side. So let's square each side. So I have to square this side, square this side. So the square root will be removed. So I'll get x plus 7 is equal to x plus 5, x plus 5, the whole square. This is plus, okay? Plus 5, the whole square. This is 5, the whole square. This is a square, okay? So I get this equation: x plus 7 is equal to x plus 5 the whole square. Now as you can see here, I have a binomial expression. So how can I simplify this binomial expression? If you remember from our previous lesson, when we discussed about a binomial expression, we saw this formula: a plus b the whole square, which is what? A perfect square trinomial. So a plus b the whole square is equal to a square plus 2ab plus b squared plus b squared. This is a perfect square trinomial. We saw this last quarter. Okay, so this is a binomial expression, so which is a perfect square trinomial. So I can apply this formula to simplify this expression. Or if you forget this formula, no problem. We just simply apply the FOIL method to simplify this expression. But for this case, I will use this formula. So for x plus 5 the whole square, our a will be x and our b will be 5. So I can easily simplify. So it will be x plus 7, okay, is equals to, our a is x, so it will be x squared plus 2 times 5, okay, to ab, which is 5x to ab, it's like that, plus 5 squared. Okay, I apply this formula. Then I'll simplify the expression. So I'll get x plus 7 x plus 7 is equal to x squared plus 10x plus 25. Okay, this is 25. As you can see, I'm going to get a quadratic equation. So let's group like terms. So I will remove x and 7 from this side. Okay, that means I have to subtract x and 7 from each side. So the whole thing becomes 0 here. So I will get 0 is equal to x squared plus 10, x minus x will be 9x plus 18. So I get a quadratic equation. So let's solve this quadratic equation. X squared plus 9x, this is x, okay, 9x plus 18 is equal to 0. Then I will solve this one. To solve this one, I will factor this quadratic expression. So when I factor it, I will get x plus 3 times x plus 6 is equal to 0. Then I will apply the zero product property. This time this is equal to 0 means either x plus 3 is 0 or x plus 6 is 0. Then x will be negative 3 or x will be negative 6. So I get two answers, x equal to negative 3 and x equal to negative 6. And as we said earlier, whenever we have a square root equation, it's very important to check the answer. So let's check our answer. So to check the answer, I just simply plug each values of x that I get into the original equation. So first let's check negative 3. So it will be negative 3 plus 7, which is under square root, minus 5 is equal to negative 3 because our x is negative 3. So negative 3 plus 7 will be 4. The square root of 4 will be 2. 2 minus 5, it is negative 3. So negative 3 is equal to negative 3. So this is correct. So negative 3 is our solution. Let's check for negative 6. The square root of negative 6 plus 7 minus 5. Is it equal to negative 6? Let's simplify it. Negative 6 plus 7 is 1. The square root of 1 is 1 minus 5. So 1 minus 5 is negative 4. And negative 4 is not equal to negative 6. Okay, therefore negative 6 is not our solution. So negative 6 is an extraneous solution and x equal to negative 3 is our solution. So on problem 4, we checked the extraneous solution. So by this we finish the lesson, and if you have any question, you are welcome to ask me on our school Logi program. Thank you very much.